In this video, we will present an overview of the predictive power of uncertainty quantification based on a case study. A leading engine manufacturer, which we'll call Company A, was making cyclically loaded steel parts and was presented with an opportunity to switch to a cheaper manufacturing process. Company A decided to have two engineering groups predict the results of the new manufacturing process. Group 1 used Company A's standard testing and simulation methods, and Group 2 added uncertainty quantification. Group 1 ran simulations and tests on the new manufacturing process. They observed an increase in the component's average strength, which meant a higher safety factor or an expected improvement in the component's reliability, so Group 1 recommended an immediate switch to the new process. Group 2 used uncertainty quantification to predict the distribution of part strengths for the new process. Group 2 discovered that the average strength of the parts would definitely increase, but the variation in strength would be much larger than anticipated by Group 1. More parts would not meet the minimum strength requirement and would fail in the field. Group 2 recommended a redesign of the process to reduce the variation. Group 1 did not get an accurate prediction of how the variation in process outputs would impact part strength, and the quality control group would have identified the problem only after many parts had made it to customers and been put into service. Profits would have gone up for a while as they shipped the new parts, but a few years later the parts would have begun to fail at an unexpected rate. Customers would have experienced unintended downtime and the company's warranty costs would have skyrocketed. By finding the problem early and advising a redesign, Group 2 saved Company A significant costs and helped to maintain its reputation for reliability. So how did Group 2 use uncertainty quantification to find the problem? Group 2 used targeted design of experiments for their initial simulations, and the results were automatically calibrated with physical test results to predict a more accurate range of responses for the steel parts. Group 2's prediction process revealed the higher number of failures due to the increased variation early in the design cycle. This allowed the engineers to redesign the parts to make them stronger and to reduce the process variation. Performing a sensitivity analysis on their previously calibrated simulations would highlight the most efficient way to create a new design and reduce the risk of failure. In this particular case, using dedicated uncertainty quantification software did make the design process slightly longer for Group 2, but that was offset by large savings in warranty costs, increased product uptime, and greater customer satisfaction. This was an overview of some of the many ways uncertainty quantification can enhance the simulation and testing process. To find out more, send us a message at contact@smartuq.com.